Analyzing data using basic graphs in R. Some of the base graphs that are used in R are scatter plot, box plot, histogram, bar graph, line graph, and pie chart. Selection of graph depends upon what would you like to show through your graph. So if you want to compare the data, you can use different types of graph for that. Based upon if it is based you are comparing items, so you can use column charts, bar charts, depending upon the items you are using. Or if you are using you want to show the data over the time period, changes over the time period, for that you can either use cynical data. That for that you will use area chart, line chart, or column chart. If you want to show distribution of data, it depends on single variable or if there are two or more variables. If there are single variables and you want to show their distribution, you can use histogram or line histogram. If you are using two or more variables, for that you can use scatter chart or area chart. If you want to show the composition of your data, it can be over a period or on a static basis. If it is on a static basis, you can use pie charts. Then there is waterfall chart and stacked column charts. If you are showing changes over the time, for that you can use column charts, stacked column charts, and stacked area charts. If you are showing a relationship between a data, it can be two variables or three variables. If there are two variables, you can always use scatter chart for that. And if there are more than two variables, for that you can use bubble chart. So let's start with scatter plots. Scatter plots show a graphical representation of the relationship between two numbered sets. So if there is any data set having two variables, for example, if there is height and weight, so if you want to show a relationship between them, you can always use scatter plots. The scatter plot is great for showing what a distribution of a data point look like. So they compare the x-axis and the y-axis and plot the points according to the data available, showing a relationship between both the axes. Then drawing a line to of a best fit for regression analysis. So whenever we are doing regression is a relationship establishment between two variables. For example, in the graph, you can see relationship between ad and revenue. So for that, there is a dotted line you can see, which shows there is a positive relationship between ads and revenues. The function that is used in R to plot scatter charts or scatter plot is plot, and within the brackets there will be different aesthetics that we will be discussing about. Next are bar plots. Bar or column charts are used to compare different items, and those items when we are comparing categories of the data. So whenever we are using bar plots, the data has to be in categorical form. All the bars are of equal width and height depend upon the numbers that we will plot according to the data. The function used to build the plot or bar graph is bar plot. Next is histogram. It shows the frequency distribution of a set of continuous column such as weight, height, or how much time a course will take, etc. The graphs are the percentage or the number of instances of different categories. So they show the percentage of different variables that are in continuous form, the x-axis or the variable you are taking. So whenever we are creating a histogram, only one variable is used, and one variable is on the x-axis, which is grouped into ranges. The function that is used to plot histogram is hist. Within the bracket there will be aesthetics and the labels and x-axis, y-axis details. Next is box plot, the method of graphically depicting group of numerical data through their quartiles. So quartiles are the 5-number summary of the data set, which includes the minimum value, the maximum value, the median and first quartile, and the second quartile. So first quartile is the difference between the minimum and the median value. and third quartile is the difference between median and the maximum value. It can tell you about your outliers and what their values are. So box plot is very helpful to plot the outliers. As you can see in this figure, there are quartiles. This is the maximum value, minimum value, the median value, and this is the outlier or the value that is out of the data which can be affecting the analysis of our data. The function that is used in R to plot box plot is box plot. Next is pie charts. So pie charts used to show the part of a whole. So it represents in percentages and the total sum of all divided segments equal to 100%. The pie charts can only be used when there are less items or less variables. Otherwise, it will be a messy or hard to read graph. The pie charts help us to divide the data which equals to 100%. It shows the composition of any of the data sets. The function used is pie. The next is line graph. So the perfect solution for showing multiple series of closely related series of data. They are great for a minimalistic look. It reveals the trend or change over time. So line graphs helps us to show the data set with how it changes over the time. For example, the stock price, variation in the stock price, or you can include the number of visitors over the site. So it shows a continuous data set and helps to build a relationship with that. Next, we are showing the aesthetics that are used for building graphs in R. So there are four main aesthetics that we will be discussing about. So first is color. So whenever we are building a graph, creating a graph, to make it attractive, we should always use colors and different type of lines and different shapes and size of the points that we are using. So first is color. There are multiple options that we can use to color, like if we are plotting a graph, so there are default plotting colors that can be recycled. So if there are multiple variables, you can always recycle the colors using 3 and 10, changing the same colors different for different variables. Then there is colors for axis annotations. If you want to color the axis names, for that we use color.axis. Then there is call.lab for coloring the labels. Then there is call main. So if you want to change the color of the title you are giving to your graph, for that you can use this command. Then there is color for subtitles. If there is any subtitle you are adding, you can change its color also. Then you can give the background color to your graph also. Next, it is line. So you can change the lines in following options. So there are two commands for that. One is LTY and LWD. So LTY is the line type. You can see there are number of line types mentioned in the picture. So there is straight line, dotted line, dashed line, dot and dashed line. So there are different types of line you can use depending upon the number. So if you want line type to be 6, so you can do LTY equal to 6. So it will be like the top line you can see it is the small dash and a bigger dash. Then there is line width. For that the command is LWD. You can always make the size of the line big, or it can be a thin line. Next is the plotting symbol. So plotting symbol can be of different shapes. For symbols, the numbers are from 0 to 25. There are 25 types of symbols that you can use to plot your data. For the command that is used to give the name to plotting symbol is PCH. So you can type PCH equal to the number of that symbols. If I want to take a big circle, so it is 21 here. If you want to take a percentage square sign, it is 22, and downward arrow it is 25. So similarly you can take different type of symbols. Then there is text and symbol size. So if you want to take a large size or a small size, for that command is CEX. You can always change the size of the plotting point, the axis point, the label size, and the title size. You can always change their size with the command cex. For that, you can take 1 as a default. 1.5 will make the size to 50% larger, and 0.5 will make it 50% smaller. Now let's go to R and create codes for scatterplot first. Boxplot is a method for graphically depicting groups of numerical data through their quartiles based on a 5-number summary, that is minimum, first quartile, median, third quartile, and maximum value. And it also helps in finding the outliers. So the formula we use in R to make a box plot is first giving the variable for which we are creating the box plot, or it can be a two variable formula. Then the title, giving the labels of x and y axis, the symbol, color if you want to give to your box plot, and horizontal or vertical box plot if it is true or false. So let's start making a box plot. So here we are showing mean of MPG using boxplot. So the formula for building a boxplot is type of boxplot function within the bracket. Give the name of x variable, that will be mtcars MPG. So I am using MPG here, and I am using color green. So let's execute this command. So you can see I've created a boxplot here. It is a basic boxplot with highest value and the lowest value median. The area between the box is called the interquartile range. Now we are adding a AB line. So we will add a line to show the mean value of MPG. You can see it is the mean value of the data set wherein it shows the mean of MPG. Similarly, you can also give lines for quantiles. What I am doing is I have given the formula AB line, which gives you a straight line with whichever formula you want to use. So I am here giving quantile of MPG column of mtcar data set. So it is showing the highest value. Then there is the first quartile, then median, then third quartile, and the minimum value line. Next, we are building a box plot for MPG, where so you can see this in the graph that is built. It is a vertical box plot. Now we will be creating a horizontal box plot. For that, we are adding a subcommand, that is horizontal is equal to true. T is for true. Let's execute it, and you can see the shape of the box plot is now horizontal. So here the values which were on y-axis, now they are on x-axis, and the direction of box plot has changed. Next, I am making a box plot with a formula wherein I am using the dataset insect spray. So let's see what this dataset is all about. It is the count of insects in agricultural experiment unit treated with different insecticides. So the data frame is of 72 observations and 2 variables, that is the numeric value, the count of insect, and the type of spray used on them. If you want to check the values, you can use head command for the first 6 values of the data set. So you can see there are count and spray variables, and there are values, the count of insects, and the spray type used on them. So total there are 6 types of sprays that are used, A, B, C, D, E, F, G. The next, I am using boxplot formula to create a box plot wherein I have given the count with respect to spray and dataset name. Then the color is light gray that I have used here. So let's execute, and you can see a box plot has been created when the x-axis is spray and y-axis is the count number. And for each of the type of spray, a different box plot has been created. And you can also see the outliers here with a single point. In the C spray, it is the outlier. Outlier means it is a large value that will affect the mean, median, or maximum out of our range of the analysis of box plot. Next, we are using a sub command, that is notch. So notch is used to compare the groups. In notched box plot, if 2 boxes notches do not overlap, this is a strong evidence that medians differ. So first let's execute this. In this case, I'm taking blue color for the box plots and I'm saying notch equal to true. So you can see what happened is the shape of the box plot has changed and there are notches wherein we can see if the notches do not overlap. So you can see they are overlapping, which means the median for each of the tray type is same. If they would not have been overlapping, the medians would have differed. So the notch, it explains the confidence intervals. That default is 95% confidence interval for the medians of each box plot, which means if the difference between the median and the second quartile and the distance between median and the third quartile are extremely different, as you can see in this last insect spray, or the sample size is very low, the notch will be wider. So you can see the notch is very wider here in the right one. If it is wider enough, that's the notch boundary is more extreme than the second or third quartile. That is, these are extremely different. The notch box will display like this inside out. So it is seen inside out. So it means they help us to understand the confidence level by which the mean is calculated, and if it is wider, or if the difference between the quartiles are wider, the shape will be inside out. Let's go for one more example using empty cars data set. Now I am saying MPG with reference to cylinders. So and data set is empty cars. I am giving the name of my x-axis as number of cylinders and y-axis as miles per gallon. Notch is true. So the shape should be like inside out and they should overlap. The data should overlap in order that it means are same for the data, and the title will be mileage data. Colors, I'm taking 3. In this case, the MPG is based upon cylinders and my cylinders are 3 in count. So I have taken 3 colors, green, yellow and purple, and then I have named them as high, medium and low. Let's execute this command and you can see 3 box plot has been created and they are notched, and there is one outlier in the low box plot data. So if I would have done it false, so they have, so you can see it is a normal box plot. The data is not notched here. So box plot is easy to understand. By using it, we can get the values of maximum, minimum, median and quartile values and the outliers in our data. Bar plots helps to compare different items. They are often used when comparing the categories of data. So let's build a data frame and then we will be building a bar plot on that data frame. For that, I am creating 3 vectors first. First is for cars, then trucks, then SUVs, and we will be merging it to a data frame. And next, I am creating a variable autos data with formula data frame and giving the names of all the vectors. So if you want to check the data of autos data, so you can see this is the data frame that we created. Now we are creating a bar plot on it. For creating a bar plot, the formula is bar plot. Within the brackets, we will give the different aesthetics. The first is the data set or the column that you are using. So I'm building a bar plot for a single category of autos data, that is cars. I'm giving the title to my graph as auto data, then X lab, that is the X axis label, then the Y label, then name of arguments. So these are the different names that will be given to each of the columns that will be created, each of the bars. Then next is the border. So the border of each bar will be blue, and density. So density is the within the bars, what will be the shade that will be given. So first I'm removing this density and you can see what the bar plot first. So you can see there's the x-axis having Monday, Tuesday, Wednesday, Thursday, Friday, and all the numbers have been the totals around y-axis, and the density right now is filled with light gray color, border is blue. Now if I give density, I'm giving a aesthetic density here, with, like, I have 5 bars, so I'm giving 5 numbers here with 10 density, 20, 30, 40, and so 50. That's executed. So you can see the number wise the density is changing. So first, when I have given 10, it is the light density inside the bar, and similarly the last one is with high density shape. Now I'm creating a data bar plot with adjacent bars using rainbow colors. Now I'm using whole data set right now, and it will be a multiple bars adjacent to each other. For that, I'm converting the autos data, that is a data frame, to a matrix, and giving the title of the data of the graph as autos, y label as total, and beside is equal to true. So what does it make? Give the differences, like right now each bar is different from the other. When I do besides, the change will be, you can see for cars, the bars are adjacent to each other. Like the number was 13649. So it is grouped together and with each other beside each other. Similarly for trucks and SUVs. The colors have been taken as rainbows, rainbow color, with 5 colors of rainbows. So you can see each of the bar is of different color of the rainbow. Then we will give the legends to this graph. We will be giving the position as top left. So top left will be here. You can give any other position you want. It can be bottom left, bottom right, top right, or the only top, which will be given on the middle of the graph, center of the graph. Then the name of the legends, that is Monday, Tuesday, Wednesday, Friday. CXC is 1. So the size of the legends will be default 1. BTY is the type, that is the BTY is the type of box in which the colors will be filled in, and I'm taking rainbow as fill. As you can see, we have taken rainbow for plotting the bar plot. So let's execute it, and you can see a legend here wherein different days has been mentioned and rainbow colors has been filled in it. Next, we will be building a bar plot wherein we will be transposing the data, and different shades of the color will be filled in. So next I'll be using heat colors, and 10% of the space between each bars, and make labels smaller with horizontal y-axis. So now the data will be transposed, therefore the axis will be y and x will be transposed. So you can see inside the bracket I have transposed the data frame. I have given the title as autos, y lab is total, colors I'm taking heat colors, and the number is 3. So I am taking 3 heat colors right now. Space, what does space do? Space will give the gap between each bars. Says CXC axis, it is the axis size of the axis label. It will be 0.8. Default is 1. I'm reducing the size to 0.8. So next is LAS. So what does LAS do? As you can see in the current graph, in the y-axis, the numbers is in slant. 0, 5, 10, 15 are in slant. If I do make it 1, it will be in the right direction, upright direction, top bottom direction. You can see the change once I execute this command. Name argument. So the x-axis will be named as Monday, Tuesday, Wednesday, Thursday, Friday, and the size of that of the point graphs will be 0.8. Let's execute it. So you can see the data has been transposed. So how do you know the data is transposed and how is it created? So my data that I created was autos data. This was the original data that I created. If I transpose it, the command for transposing is T. So the columns and rows has been reversed. There are now 3 rows and 5 columns. Similarly, the graph has been changed because earlier there were five columns. If you want to check that, see, there were 5 bars here for 5 columns. If I transpose this data and plot the graph, the bars are stacked and there are only 3 stacks there because the data is transposed into trucks, cars and SUVs. That means 3 rows. And the title I have given is autos. Now you can see Monday, Tuesday, when the days are in small font. If you want to increase the font size, you can increase the cxe.access value. I have taken 0.8 earlier. Let's take 1.5 here. And the last, you can see the change with last equal to 1. The y-axis numbers, the direction of them has been changed. If you want to see the change, I'll make it to 0 and check the values. Here also 1.5. So you can see the y-axis numbers has been changed to has been increased to 1.5. Similarly for x-axis, and the last, if I what I did was last equal to 0, then the direction of y-axis numbers have been changed. So I'm again doing it to 1 and reducing the font size because it looks messy with large with alphabets. So let's make it 0.8 again, or you can take 1 as a default. Now let's add legend to this. I'm adding legend to top left, giving 3 names that are the rows, the cars, trucks and SUVs. Then the CXC size, the size of these fonts. Then the square boxes for the box type, and filling the colors with heat colors that I have used for bars. You can see if you want to change the direction of this legend, what we can do is we'll just do a top here and remove left. You can see the position has been changed to top, that is the middle on the top row. Or you can do it will be best where the graph is empty to create a legend there. My right side has been filled with the bar, so I'm not taking legend on that side. It's better to take on top left. It is more tidy and better to present. So the bar plot is easy to create. It helps us to compare different items. Like you can see, the red color here in this graph is for cars, orange is for trucks, and yellow is for SUVs. On Friday, the number of SUVs used are highest, and on Wednesday, you can see the number of cars used is around 8. So it helps to compare the data. If you create a general data, like we have created this, so you can see on Fridays the number of used cars is the highest, that automobiles used on Friday are the highest count. Histograms, it shows the frequency distribution of a set of continuous data. So let's build a histogram for a random normal distributed data. For that I'm using rnorm function here with a value of 1000 variables. The function that is used to build a histogram is HIST, that is hist. So let's execute this command, and you can see the graph is showing a normally distributed data. If you want to build a data for a that is skewed data, that is not normally distributed, it has different values and frequencies. There is an inbuilt dataset that is islands. So it is a dataset having the area of different islands. It's a vector of 48 length. Let's execute this command, and you can see it is a skewed data. That means one side the variables or the value is high and the other side is very low. Then there is, you can see in the graph, the values of y-axis, this shows the frequency, that is from 0 to 10, 20, 30 and 40. If you want these values in the form of density or probability, what you can do is you can add a sub function, that is probability equal to true or frequency equal to false. It goes each way the same. So if I execute this, so you can see because it is a very small value, so it is showing the scientific format. Let me give you an example. This was the data of normally distributed data. If I want the density to be shown on the y-axis instead of frequency, I will be taking the same formula, that is the HIST inside bracket rnorm. Rnorm is for random variable number, taking value of 1000. And next I will be doing probability equals to true. It is giving me an error saying could not find function rnorm. Okay, so I have written the wrong spelling, that is why it is giving an error. So you can see the frequencies have been changed to the density. So it is 0, 0 0.1, 0 0.2, 0 0.3 and 0 0.4. Now let's go ahead. So when we are building a histogram, if you want any help regarding it, just question mark it and you will get help from R regarding all the arguments or the subfunctions that you'll be using in that formula. You will have different examples when you go down. There are examples. There are multiple examples regarding histogram. We will be building a histogram with bricks. So the function that we use is hist. Within the brackets, first you give the name of the data set or the column that you want, or a variable. It can be a single variable. Then there is breaks. The breaks is the number of bins that will be created for the histogram. So it is a continuous data. What you want, you should understand the difference between bar plot and histogram is bar plots. They are the individual bars that are created for a categorical data. For when you are plotting a continuous data, histogram helps you with that. You can see there is a continuous bars that have been joined to each other with a range of data on the x-axis. I am giving breaks here. The data that I am using here is island. If you want to check what is all in this islands data set, so you can see there are different islands along with the size of their area. So I am giving 5 breaks. So there will be only 5 bars, 5 breaks, bins. Then the title of my graph will be islands histogram. X label will be area range, and the border will be of red color, and it will be filled with gray color. It's executed. So you can see the border of my bins are of red color filled with gray color, and there are so because of the data set that I am having, it is only split it into 4 bars. Let's go ahead. There will be more examples wherein we will be breaking the bins of the data set. So next is I'm using the data set air quality. There are different variables in this data set. If you want to check the data set, it is air quality. So you can see there is ozone, solar wind, temperature, month and day. So I'm taking only temperature from this data set, and I will be working on that. First, I'm creating a histogram for the temperature variable of the air quality. So you can see it is a nicely distributed data. It is a normally distributed data. We are having y-axis as frequencies, showing the number values, and the x-axis is showing the temperature, the value of each of the days. Next, now we will be adding the labels of this graph. So for that, I am taking the title as the function for that is main. The title name will be temperature histogram. Name of x-axis will be temperature, y-axis is temperature frequency, and last equal to 1 will change the direction of frequency values, that is the top down direction. So you can see the change in the graph. There is title added, x-axis name added, and y-axis name added, and the direction of y-axis variables has been changed. Now we are adding color to the bars. So you can see there is no color. To make it attractive, let's add color to it. So I am using function, subfunction is called, that is color, and I'm taking 2 colors here. So for that I am using combine command. First is the sky blue color, second is the chocolate shade. It is the second shade of chocolate. So let's execute, and you can see it is more attractive now. The graph should be attractive so that viewers get interested in your data. Next, what we are doing is we are removing all the details of these graph, that is the annotations, the names of the axis, and the and the headings, and we will be giving our own limits and names to the accesses. So for removing, what we are doing, access equal to false, annotations and all the limits and the names will be removed. For that we are doing false. Label equal to true. So what is label equal to true? There will be numbers on each of the bins here showing how much is the frequency of that bin. Then we are adding y limit. We are changing the limit of y-axis to 0 to 35. It is already the same, so we are keeping it, and we are also keeping the colors of these bins. So you can see only the labels are shown, all the other things has been removed. Now let's specify our own annotations and accesses. So first, inside histogram, I'm taking the data set or the variable. Then I'm giving the heading, that is temperature, again same y-axis and x-axis names. Then last equal to 1. Then colors, I'm taking sky blue and chocolate 2. So now the limits are changed. So x limit will be from 55 to 100 and y limit 0 to 40. And what does density do? Density will lower down the color shade to 80%. Let's see the change. So you can see the heading has been added to the graph, x-axis and y-axis limits and the names has been changed, and the density of the color is decreased to 80%, giving the number of breaks and adding numbers to the bars. So now, as we are in frequency distribution, you can see the y-axis, we are in frequency and not probability values. So whenever we are on frequency, we can add numbers to our bars. For that, we are first giving the breaks to our data set. So earlier there is no break. It has been divided according to the data set we are having. We are providing it with 20 breaks, names of the accesses, color and labels equal to true. So the numbers will be mentioned over the bins. And I'm changing the limit of y-axis to 0 to 25. So you can see there are 20 breaks now, and there are number mentioned on each of the bins. So the temperature is 6 here, 5. Next, what we are doing is we are creating a histogram using density or probability values. For that, we will be removing all the labels, that is the value on the top of the pins, because they are only visible when the frequency is there. It is better to use labels when frequency is used as the y-axis labels, because it is more tidier to see. If you can see what happens if you will not remove the label values. So for that, what we are doing is we are taking hist command, inside the bracket the name of the variable, 20 breaks, frequency equal to false. So frequency equal to false or probability equal to true, both goes the same way. Then I'm giving the name of title, x label, y label, last equal to 1, colors sky blue and chocolate blue. Let's keep labels equal to true. So you can see you can you can check the values on the top of each of the bins, but it will convert into probability values or the density. So it is the 0.02% or 0.16 part. Now let's add a density line to this graph. So density line will help you to understand how the graph is moving, the area that is covered under the line. Let's add a density line. So the formula for that is lines. Within the bracket, the function is density for the to calculate the density of the temperature. Then I'm giving the line width as 4 and color equal to red. So it will be a red line with width of 4, giving the density of the temperature. So let's make a original graph that we created with all the features, having frequency as temperature, giving the labels to the bins. The bins have been break down to 20. There is headed to the graph as temperature histogram, x-axis and y-axis names. Pie charts. Pie charts are used to show parts of a whole It represents numbers and percentages, and the total sum of all the divided segments equals 100%. So for that, we will be first creating a vector that is cars with different values for each day. So there is Monday, Tuesday, Wednesday, Thursday, and Friday. So it is like on which day how many cars has been used. It is a very simple formula to make a pie chart. The formula for that is pi within brackets name of the vector. So let's execute it. So you can see the pie has been created showing 100% that has been divided into 5 parts. The numbers were 1, that is the 1%, 2, 3, 4, and 5. 5, the fifth value was 9. So the area of fifth part is large. Similarly, we can custom the colors for that and add labels to the pie chart. For that, the command we are using pie within the brackets name of the vector. Then the heading of the graph that will be cars. Then colors that we are using is rainbow, and length we are giving inside rainbow is length of cars. So the numbers that are in cars equal to that the colors will be selected from the rainbow shade. Then labels are the name of each of the parts it is divided into. So there are 5 parts: Monday, Tuesday, Wednesday, Thursday, Friday. So each one will be given the name respectively. So let's execute it, and you can see the one is changed to Monday, Tuesday, Wednesday, and color has been selected from the rainbow as per the length of vector car. Then define some colors ideal for black and white print. So now what we are doing is we will be creating different vectors, and after that we will be creating a pie chart for that. For that, first I am taking a vector for colors that will be selected for this pie chart. So there are shades of white and black. So first is white, then there is different shades of gray, then there is black. Let's execute and save this vector. Now we will be calculating the percentage of each day rounded to 1 decimal point. So for that, what we are using, we are creating a vector car labels. Labels are the names like we have given Monday, Tuesday, Wednesday in our pie chart. Instead of that, now the percentage will be printed here. So we will be calculating that percentage and rounding it to 1 decimal point. To round it, we are using the command round within the bracket. It is the simple mathematic formula, the vector name divided by the sum of vector into 100. Into 100 is for percentage, and cars, like if it is 1, it was 1 divided by the sum of this vector. So 3 divided by the sum of this vector, 6 and so on. So let's execute this. If you want to check this vector, these are the values that have been calculated, which means the first part that will be divided into is 4.3, then 13%, 26.1%, 17.4, and 39.1%. Now we will be pasting percentage sign with these calculated values. For that, we are using paste formula and giving the name of vector. So in this vector, I want each variable, each value along with that percentage sign to be attached with the separator space. I have not mentioned anything, so there will be no space between it. You can give a space here. Just press a space bar, then there will be a space here. So it is like 39.1 space percentage sign. Let's execute it, and you can again check the variables. So you can see there is 4.3%. So because I have taken a space in this separator, so there is a space here. Now I am creating a pie chart. For pie chart, the first thing is the vector name. So it is the car that has to be created as a pie. Then the name of the title of the graph is cars. Colors will be the colors vector that we created here, shades of white and black. Then labels. Labels I am giving and that we calculated the percentages along with the percentage sign, and CXC equal to 0.8. So it is the size of the labels that will be adding to our graph. So you can see each part of the pie has labels of their percentage that they are divided into. Next, I am adding legends to my graph. For that, the command is legend. Inside the bracket, the first thing is the position of the legend. So it is, I'm taking top right in my graph. Then there is name of each of the legend, then the size of the legend text, and the colors. So to fill the boxes with the colors that we have mentioned in this vector. So there were shades of white and black again. Let's execute it. So you can see a legend box has been added to the graph. Now, if you want to create a 3D pie graph, for that there is a package that is Plotrix. I have already installed this package. You can install it through package tab here, or just give the command install.packages and within the bracket name of Plotrix. Now I will be loading this with the command library. I'm creating a vector slices and with some values in it, and let's create this vector. And there is one more vector that is for labels, and giving each value a name, that is US. Then there is division of UK, then Australia, Germany, and France. Now the formula that we use, that is inside the package that we just installed, Plotrix, is pi3d. Within the bracket, give the name of the vector that you want your pi for. In labels, the name of the label vector. Then explode. So now explode means each division of pi will be separated with a gap. It shows that value. So explode 0.1 means it will be near to each other, but there will be a gap in each division. Then there is main, that is the title of the pie chart. Let's execute it. So you can see there is a division in each of the pie divide segment, because we have taken explode equal to 0.1. If you increase this explode value, the difference in the gaps of the segments increases. So pi is a good graph, is a useful graph if there are less values in your vector or the variable that you are using in your data set. If there are less variables, you can always use pie chart. But if there is large value, it will be a messy graph and it will be not useful, as the viewer will not be able to understand the graph. So you can always use a 3D graph to present few items of your data set and make it an attractive graph. Data visualization in R using ggplot package. ggplot is the visualization package that is used in R. It helps to create very intricate packages and great looking graphs. It is also called as grammar of graphics. ggplot consists of various parts of graphics, or also called as layers of ggplot. We can add multiple dimensions to our of our data set to the graph. So ggplot helps us to create very intricate and great looking graphs that are very multi-dimensional. That means we can add multiple variables of our data set to the graph, which makes our data attractive. So that's why it is called as grammar of graphics. So in advanced graphs using ggplot, we will be covering scatterplot, bar graph, and heat map. So different layers of ggplot that are involved in our graphical representation is, first is data layer. So data layer is the data frame or the data set that we are using for our graphical analysis. Next is aesthetic mapping. So a set of aesthetics mapping specified using AES function and combined with plot defaults as described in aesthetic mapping. So aesthetics are the features that we are adding to our graphs, such as shapes, color, and size of the data points that we will be plotting. Next is the geom layer or the geometric layer of the ggplot. So it helps to identify what kind of graph we are creating, whether it will be a scatter plot, bar plot, or a heat map or line graph. It can be any kind of graph that you want. So it comes under geom layer. Next is the stats layer. So stat layers, statistical transformation performs some useful statistical summary, is key to histogram and smooths. To keep the data as is, use identity as stats. So stats help us to give the counts or any of the statistical function that we need in our graph. We can give that function under stat layer. Next is the facet layer. So facet layer helps to partition a plot into a matrix of panels wherein each panel shows different subset of the data. So as per a categorical or a factorial data of your variable of your data set, you can divide the graph into multiple subsets and create different plots based upon the subsets. Next is the position adjustment. So it helps us to help the objects or the points that you are plotting on your graph to position them and adjusting the text of your graphs. So let's go to R and create some beautiful graphs using GGPlot package. GGPlot is the grammar of graphics. There are different layers in it. First is the data layer, second is the aesthetics, then geometry, then statistics, position, and facet layer. So let's start with scatter plot first. The package that we want for ggplot is ggplot2, and if you when you want to download this package, you can either download it from package tab here, install, or you can give the command install.packages. So I already have this package with me, so I'm just masking it to my screen, my session, using library command. So let's execute it. And the other package that I want is dply package in order to manipulate my data in order to get a better result out of it. So the data set that I am using for my analysis is empty cars data set. You already know about this data set. It is an inbuilt data set having 32 rows and 11 columns, that is 11 variables. We will be taking different variables using will be used to create our graph. We will be at least using 7 of these variables added to our graph. Let's see how to do that. So first I am showing you how a basic graph for weight and mpg look like. So a base graph, for a base graph, the function is plot, and the x-axis is weight and the y-axis is mpg. So when we execute this command, this kind of a basic graph is created. Next we are adding, so let's start creating ggplot and adding first layer of ggplot. For that, the function is ggplot, which is inside this ggplot2 package. Within the bracket, first thing we mention is the data set or the data frame you are using. So my data set here is empty cars. Then the aesthetics. So the aesthetics for ggplot layer is very important. You have to give this aesthetics layer inside ggplot function. Within aesthetics, first thing you are mentioning is the x-axis, then you are mentioning the y-axis. So with this layer, no graph will be made, but a base for the graph will be created. What is the base for the graph? Let's execute and check. So this is the base of the graph. There is no plotting yet, but a graph has been created with x-axis and y-axis. So these are the basic aesthetics that we want for our graph. Next, we are adding a geometry to our graph. To add geometry to the graph, which means there can be different kind of graphs that you want. There can be bar graph, there can be a scatter plot, heat map, line map, any of the graph you can create to add a geometry. The function is geom for geometry, then underscore. Then you can see there are different kind of functions that you can use for different kind of plots. Here I am doing the scatter plot. That means we want points. So it is geom dot point underscore point. And I'm not giving any aesthetics right now. I just want points to be added to my graph. So you see, points have been added to the base of my graph. Now I will be adding aesthetics to this graph. So the basic aesthetics that we want is color, size, and shape. So first we are adding color and size to the points. The color that I want is red. So whenever you are mentioning a color, a basic color, you will have to be mention it in inverted commas, and size can be of any point that you want. I have taken 3 here so that they are little bold. Let's execute it, and the geom layer will be added to the basic graph, otherwise the plots will not be created. So you can see the color has been changed and points are bold now. They are bigger in size. Now let's add shape to this. points. So shape means instead of circle, I want a different kind of shape to be pointed. Here I have taken 20. You can take any of the number within 25 shapes that we have already discussed. So we have taken 20 here. So the points have been changed to diamond. You can take any type of shape here. So if we take 5, so you can see the shape of the points have been changed. But let's take it 20 otherwise. So it is better to look at. Now what we will be doing is we will be adding aesthetics layer to the geom point. So what was the difference between this when I was saying I am adding aesthetics in the form of color, size and shape, and again I am saying I am adding aesthetics, which means earlier I was giving basic commands that were color, size and shape. Now we will be adding dimension to our ggplot. So we will be covering new variables in our graph. We have already used weight as x-axis, mpg as y-axis. Let's see what are the different variables available with us. So you can see there is cylinder, then there is transmission, gear, carburetor. So let's try to cover these variables in our graph too. So if you see cylinder, gear and carbonators, they both they all are categorical variables. How do we know that? Table, we can count them easily. They are not the continuous values, they are categorical values. So if you check for cylinders, so you can see there are 3 type of cylinders. Similarly, if you want to check for gears, so you can use table command and you can check there are 3 gears. And for carbonators, empty car, dollar, then there is car. So you can see there are 8 kind of carburetors. So let's add them to our graph. And there is AM also, that is automatic or manual transmission. If you want to check how many type of transmission are there, then there is empty cars, dollar, AM. So we know what all are our categorical variables in our data set. So what we will be doing is we will be adding them to our graph. So first, if I give the cylinder to be colored as points to be colored as per the number of cylinders. If I give it directly as a basic function, let's see what happens. So it gives us an error in layer, geom point, object cylinder not found. So it is not able to find this cylinder value. What is the cylinder? It is not able to find that. So this is wrong. We cannot do it like that. Let's comment this statement. Next, what we are doing is, so now what I was saying is I will be adding aesthetic. So here I haven't given any aesthetics function. Now I am adding aesthetics for cylinder, only for the color part. Rest is the basic function. So let's execute it. At this point, I haven't converted into factor or categorical. It is still in continuous form. So you see we have here 3 cylinders, but by default it has created different cylinders because it has taken it as a continuous value, which is wrong. It has not taken the value correctly. So let's convert it to factor and then make it color. So now you can see the points have been divided as per 3 types of cylinders. So we have added one more dimension to our graph. So there is weight, then there is mpg and colors as per cylinder. So if you want to, what do we get out of this graph is there are the number of cars which are in blue. They have 8 cylinders. They are from above 3 weight and less than 20 mpg. So they have 8 cylinders. Similarly, the highest cars with highest mileage and lowest weight, they have 4 cylinders. So you can analyze it from your graph. So let's add one more point to your graph. Now we are adding size as per transmission. So let's execute it. Now because you are adding one more dimension, you will be including it into your aesthetics function now. Let's zoom it and see what happened. So you can see as there were 2 kinds of AM, that is automatic and manual transmission. 0 is for automatic and 1 is for manual, and 3 types of colors, that is 3 type of cylinders. So you can see points have been changed to bigger and smaller sizes, small one for automatic, bigger one for manual cars. So the cars with highest mileage and lowest weight are the manual cars, with 4 cylinders. So you can see what all you can analyze from your graph. We have added 4 dimensions to our graph. Next we are adding gears for our shape. So there is one more dimension added to our graph. Let's see. So let's zoom it and see what happened. Now there is one more factor added, that is gear. So how does it added? The shapes has been changed as per the number of gears. So what can we analyze is the maximum mileage cars and lowest weighted cars are of manual transmission having 4 and 5 gears and are of 4 cylinders. So you can see what all you can analyze from your graph. There are so many variables added in one graph only. So how GGPlot is powerful and how can it help you to build a graph? Now we are adding labels to our graph. To add labels to your graph, there is one more layer that we are adding, that is labs. Labs, that means labels. Within the graphic, within the bracket, the first thing we are mentioning is the title. So title is adding dimensions to graph. Then there is subtitle. Then there will be a small title, that is scatterplot. Then axis name and the y-axis name. So let's execute it. You can see there is a heading. Then there is subheading, and y-axis, x-axis names has been changed. Let's add more dimensions to this graph. So what more we can add is, we can add facet layer to this graph. What will facet layer do? It will add one more dimension and will split the graphs into subsets. How can we do that? So adding facet layer and adding dimensions to graph. So till here, till geometric layer, the formula is same that we used earlier. Labels are same. What we are doing is we are adding a facet layer here. So now what we did is facet grid. So what does facet grid do? Facet grid will divide the graph with VS versus carburetors. So VS is a type of engine, whether it is a straight engine or a vertical engine. If you want to know what it is all about, you can just question mark empty cars here. So VS is type of engine. So it is V-shaped or a straight engine. 0 is for V-shaped and 1 is for straight. So let's go back to our plot, and we are adding facet. Let's see what happens and then I'll explain further. So you see the plot has been split into subsets of the data set and 2 more dimensions has been added. Let's zoom it. So there were 8 types of carburetors here. So the data has been subsetted into 8 parts and 2 of the VS parts. So if you want to analyze it, how can you analyze it? So this part, this panel, what does it show? It shows there is a car which is of manual transmission, have 4 cylinders, weighted between 2 to 5 and of mileage from 25 to 30. So you can see, and I have 2 carburetors and is of V-shaped engine. So how many variables you can analyze from one graph? So these small points, what does they show? They are of 8 cylinders, mileage from 20 to 15, weighted between 2 to 5 weight, and what else we can understand? The AM, that is they are automatic cars and are of 3 gears. So how powerful is GGPlot, and it can help us to understand the different variables in one graph. Let's go ahead. So we added, let's do one more facet add. Let's add one more dimension to our facet. Now what we are doing is we are again splitting the graph. We have already given the one of the variable, that is cylinder. We are again adding it to the facet command. So if you want to add one variables to your facet, that how many subset can be created, you can add that to your facet here. So let's execute it and see our graph. So you can see what happened. Our graph is more subsetted based upon the cylinders. So 4, 4, 6, 6, 8. So there were 3 kinds of cylinders. So how are they subsetted? So 4 cylinders and with a V-shaped engine, 4 cylinders with a straight engine, 6 cylinders with 0, that is V-shaped engine. Then there is 6 cylinders with a straight engine. So how how many different dimensions you can add, you can see in this graph. And let's see how to analyze this graph. So what this car is showing, this car shows that it is of manual transmission. Then it is 5 geared car. Color is pink, so it is 4 cylinders. It is of 4 cylinders. Here also you can see there are 4 cylinders, and there is V-shaped engine, and it is between 30 to 25, 25 to 30 of mileage, and the weight is 2 to 3. So there is and of 2 carburetors. So how many factors we have added to our graph, and the graph is very interactive now and very intricate. So in a graph we can at least add 7 dimensions, making it interactive and precise to our need. Now if you want to position your labels, so for that the command is geom text. You have to give the aesthetics inside that bracket. For aesthetics I am taking labels inside it because I want labels to be added to my points. How the name of each of the car will be pointed with each of the points. So and the size of the name of the car is 2.5. Let's execute it. So you can see the names of the car has been added to our graph, but it looks little messy. It looks cluttered. Let's add one more package to this graph in order to make it tidy. So how can we do that? There is a package. So let's remove this cylinder one from here. I am removing cylinder from my facet so that it is little less cluttered. And the package that I am using in order to label my cars here is GGPlot. So it helps us to make the labels tidy. Within this package, the function is geom underscore text underscore repl, and the function is same, that is aesthetics within the bracket label equal to row names of the car, and size is 2.5. So let's zoom it and see what happened. So you can see the car's name are more tidy now. And so this car was Porsche 9142. So this is how you can name the points and add different dimensions to scatter plot. The plots can be mastered using after a great practice. So keep practicing it and mastering the GGPlot. Bar plots using GGPlot package. So for that, what the package that we are using is empty cars. So let's build basic plots first. So we are creating basic bar plots. For that, I am taking empty cars dataset and I am plotting cylinders here. So there is two types how to understand how to plot a bar plot. So first, if I directly tell the R to plot cylinders, let's see what happens. So it has plotted 32 cars in different bars, so which is not correct. So for that I'm using table command here, and I want there are 3 types of cylinders and you should plot 3 bars telling the number of counts here. Let's execute it. So you can see there are 3 types of cylinders, and the y-axis tells you the total count of the cars, such as 4-cylinder cars, there are total number of cars is 11. Then there are 7 cars which have 6 cylinders, and 14 cars that have 8 cylinders. So let's create ggplot now. For that I'm using number of cylinders again. So we have already understood how to create the base of the graph. For that the first layer is ggplot, and within the bracket we are first giving the dataset name, and then we are giving the x-axis. So in bar plots, as we know, we always create bar plots for categorical variables. They should not be continuous, they should be a category. So the x-axis will be the number of cylinders that we are plotting, and y-axis will be the count. So therefore we are not giving y here because we know it should be the total number that we want to plot. So x-axis, that is the variable that I want to plot, it is cylinder. Then the geometry layer. So here the geometry layer is geom underscore bar. Like in scatterplot it was geom point. Here it is geom bar. Let's execute it, and you can see the x-axis is of cylinder and y-axis is of count. and the bars have been plotted accordingly. Now I am adding color to my geom bars. So for that I am saying fill. So here the command changes. In scatterplot we used color. Here we are saying fill, and there are two things. You can either say color, that is COL, or you can say fill. I'll show you both the functions. Fill will fill the colors inside the bar, and color will color the borders of this bar. So if you want to check that also, so let's first execute fill command, and you can see the bars have been colored as red. But if I say color, that is COL, so what happens is only the boundaries or the borders of the bars are colored in red. Other the inside is of gray color. So you should choose the function properly in order to make your bar looks better. Next, we are adding aesthetics layer to our graph. For that, I am saying whenever you want to add a dimension, you will be using aesthetics, as I have already told you. So here I am saying fill the colors according to number of cylinders. Let's execute it. So there are four types of cylinders. So there are three types of cylinders. So the three colors have been mentioned and have been filled inside the bars. So this one is for 4-cylinder cars. Then there is 6-cylinder cars and the 8-cylinder cars. Similarly, if you would have taken color, not the fill, what would have happened? The borders have been colored in different colors. The fill is same for each color. So it is not correct. So this fill is better. Next, if you want the height of bars to represent the values in the data, use stats equal to identity and map a value to the y aesthetics. So how will we do that? We'll go further in the next function. We are doing that. So next we are adding a number to each of the bar, telling the count of the cylinder. So how many cars are of 4 cylinders, that will be mentioned on this bar. So for that I am first using dplyr package for manipulation. So till here what we are doing is we are summarizing the function. For that I have grouped my empty cars data set as per cylinders, and I'm saying summarize it in the n variable. Give the number of counts for each of the cylinders, and after that after using all this value that have been saved in the n variable and grouping it by cylinders, what we will do is we will plot the graph. So we are saying ggplot. Then I have mentioned a dot here. So dot means all the values we have analyzed or summarized from this function that have to be used here. So after that I'm giving aesthetics, wherein x equal to cylinder and y is equal to n. So n is the count which have been calculated from the summarize function here, plus the geometric layer. So in geometric layer I am giving stats. So what does stat means? Stat will give you the statistics or the count of the number of cars. So for that I am using identity as a function here. There are different kind of functions. You can question mark geom bar and you will get different stats. There is count, there is identity, and there is different kind of functions. So here if you want a number to be mentioned, you will use identity here. Then aesthetics is fill according to cylinders. And also with geom text, that is the next layer, I am adding label as n here. So let's execute it. So you see the y-axis has been labeled as n, and the x-axis is cylinder, and colors have been filled according to cylinders, and there is the stat count that has been added to each of the column, each of the bars. So there are 11 cars with 4 cylinders, then there are 7 cars with 6 cylinders and 14 cars with 8 cylinders. So this is how you can add a number of count to your graph. Next, what we are doing is we are adding a facet grid, that is the facet layer. So here I am adding gear versus AM. So what will happen is we will be dividing our graph that we have created, this graph, based on gear and automatic and manual transmission. Let's execute this command and see what happens. So the graph has been divided into 6 parts, wherein the columns that are 0 and 1, they are the AM, and these are the gears, 3, 4, 5 are the gears. So if you want to see this graph, if you are saying here, what we understand is there is one car which is of 4-cylinder and is of automatic transmission and 3 gears between so it is cylinders on the x-axis. So there are 4 cylinders. So there is one car which is of automatic transmission having 3 gears and is of 4 cylinders, and so these all the variables that we have added to our graph right now. So there are 12 cars of 8 cylinders and 3 gears and is of automatic transmission. So if here if you want to see here, there are 6 cars of 4 cylinders and are of manual transmission with 4 gears. So you can see how many variables we have added to our graph. Let's go ahead. Now what we are doing is we are scaling the graph. So what does scaling means? The same graph you can see there is lot of space left in the graph. If we zoom it, you can see there is lot of space that has been left in the graph. So what we will do is we will utilize all the space in our graph by scaling our limits here. Each of the each of the pane will be rescaled and the graphs will be zoomed in and the space will be utilized. For that the function will be same, just in facet grid layer we say scales is equal to free and space is equal to free. So what will happen is all the empty spaces will be removed and graph will be zoomed in. Let's see what happens. Now you can see what happened is it has rescaled the graph and the spaces has been utilized better and the graph is zoomed in. So this is how you can change the limits of your graph also. So this is how bar plots are created, and if you want to create a basic bar plot like we have created earlier, this was the graph that we created. This was the basic graph. If you want to rotate that, it is the vertical graph. If you want to change it into horizontal graph, what you can do is you can add a coordinate flip here. So the command is coord_flip. You can see it is here. So what will happen is your graph will be in horizontal way. So here y-axis have become the cylinders and x-axis are the counts. So this is how you can flip your axis also. This was the last graph that we created with adding different dimensions to our graph, wherein we added AM, gears, cylinder, and there was count on each of the bars. Heat map, it shows the intensity of colors to depict the number of counts that we have for the dimensions that we used in our data set. So for that we are using empty cars and grouping it by cylinders and gears. So we are taking 2 dimensions here and will be summarizing to get a common count for each of the cars for cylinder and gear. Let's execute it. So this is the variable A that we will be using for building a heat map, wherein what we got is 1 car of 4 cylinder and 3 gears, 8 cars of 4 cylinder, 4 gears. So similarly all the data has been taken out. Now what will happen is how the heat map will be made. It will be depending upon the count. So let's create a ggplot for it. For that, first I'm taking is the first layer, ggplot layer, giving the data frame, then the aesthetics. Within the aesthetics, what we are taking is x-axis, y-axis. So x-axis is cylinder, y-axis is gear. I have converted them to factors in order to get a categorical value, otherwise it will be a continuous values. Then I am filling it with n. N is the number of count. So wherein the intensity of color depend upon the number that is present in n. Then the geom_tile is the geometry of this graph. So for bar we used geom_bar, for scatterplot we used geom_point. So for heat map we are using geom_tile. Let's execute it. So you see there is a graph, heat map, and legends are here. So how do we understand this graph? and the x-axis is cylinder. So there is 4-cylinder car, 6-cylinder cylinder. Then there is 3 gear, 4 gear, and 5 gear. The dark colors are of 3. The number is of 3. So it has been distributed in such a way that the light color is of more cars and dark colored is of less. If you want to give numbers to this map, what we can do is we can add a layer that is geom text. It will help you to label the points inside the graph. So for this pane, that is this square, what is the number, and for the light color, what is the number. So for that, within geom text, I am adding aesthetics label equal to n. N is the count of car and the size that I want is 6. So the size of the label will be of 6 number. So you can see there are 12 cars of 3 gear and 8 cylinders. Similarly, the dark colored ones were 1 cars with 3-cylinder, 4-cylinder, 3 gear, and 5-cylinder, 6-cylinder, 5 gears. This is how a heat map is created. What we can do is we can also change the colors. We can scale it in a gradient form. For that, the formula we can add is scale fill gradient. Let's see what will happen. So this was the first that we used, that was scale fill gradient. Then there is other also. If you want scale underscore fill underscore gradient. Then there is one more, that is 2. You can change the fills here. So this is another form of color that you can add. You can add different other colors depending upon the factor also. So this is the basic heat map that is created.